wall or stepping the floor, it will not move. And when you try to drag a table, the more force you exert, the faster it will move. Think about it. One thing more. Did you try to ride a car? How does it feel when the car suddenly stops? First law of motion is the law of inertia. It states that a body at rest remains at rest and a body already in motion remains in motion with a constant velocity in the absence of unbalance applied force. One example of it is when you try to ride a car. With a constant velocity, then it suddenly stops. Your body will continue moving forward towards the windshield. Because of this, the law of inertia, seat belts prevent the passengers from moving in the direction of the motion. The second law is the law of acceleration, stating that the acceleration of the object is directly proportional to the mass of the object. In equation form, we can state Newton's law by F equals ma. Example of it is when you push a table. The more force you exert, the faster it will move. Going to the last law of motion, the law of interaction. It states that when the object exerts a force on another object, the second object will exert a force on the first object of the same magnitude, but in the opposite direction. Or simply, for every action, there is an equal and opposite reaction. Examples are leaning on the wall and walking on the floor.
Buoyancy. As we can see in the illustration, we can easily define buoyant force. It is an upward force resulting from the object being immersed in the fluid. How can we make an object float, sink, or float underwater? Object floats when the density of the fluid is greater than the weight of an object being dispersed, and the object will sink if the density of the fluid is lesser than the weight of the object being dispersed. And if the density of the fluid is equal to the weight of the object being dispersed, the object will float underwater.
I was scalar before that came into my life and gave me direction. We became vector. This means that scalar quantity is a quantity that is only determined by a magnitude. And when the scalar is associated with the direction, it is now called vector.
And here are some examples of scalar and vector quantities.